so pretty much you could kind of say part 2 of 2-1. Just a few definitions, then we're going to kind of talk about these and then go from there. Frequency histogram. Yes. It will be a bar graph. That would be something that you might want to highlight there. That represents the frequency distribution of a data set. And we just did that. We did that whole table. Unfortunately, I erased it, obviously, but you should have it on your notes. We did. There's frequency on that last table you just did, relative frequency. I think we even did, what, midpoints on there. Again, what's another one for midpoint? Another name? Mark, yep. We even did the class intervals. We did the cumulative frequency. We did all that stuff on there. And so basically, it's just a bar graph that kind of just shows you just flat out frequency. Not relative, not cumulative, just, what was the first one? 6 was our first frequency, I think, and then 10 and 13 or something like that. And so that's what you'd be looking for there. Keep in mind with those that you can actually use the midpoint or the mark to graph those, or you can use just the class sizes, however you want to do that. It's done many different ways. Class boundaries can, basically, I just want to touch on that. It's really not overly important for the long run. But basically, it's the number that will separate the classes without forming any gaps. Because what did we have for our first one? It was like 7 to 18 was our first class, right? But that's because look at the numbers I gave you. Were there any decimals or anything like that? Because really, technically, your next one was what, 19 to whatever it ended up being. And what was it, 30? Yeah. Technically, if I were to give you a whole lot of data, is it very possible that we could have missed some if we used those classes? It is very possible. Like, what if you had 18 and a half? Where does that go? So obviously, we chose our classes because of the data we had. But for class boundaries, they would say, basically, one easy way to do it is to take your lowest and subtract a half, take your biggest and add a half, and then those are kind of your class boundaries. So you can kind of say that you're rounding, basically. So you could say anything from, say, 6.5 to 18.5, we would just kind of throw in there. Does that make sense? Those are kind of the boundaries. Because do you agree that from 18 to 19, there's a huge gap? All right. Again, this isn't the end of the world. So then this one you would start at 18.5 or 6, depending on how you want to write it. But it's easier just to say it this way. And so you just don't want any gaps in there. Because 18.5 would kind of land right on an end there. Yeah.
So you would be using that only when you have decimals?
Yeah. That's just kind of a known thing. And it's, like I said, it's so, we're not going to have to worry about it all that much. So we're going to be fine. But I wanted to bring it up because it's going to come up in something that we do in just a little while. You're going to see kind of these numbers right here, 6.5 to 8. You're going to see those numbers. And I want you to know where they're coming from instead of being like, what's that? So that's the whole reason behind showing you that. Because I think most of us would know that anyways, to do it somewhere like that. So, well, wait a minute. If a frequency histogram is a bar graph that shows the frequency distribution, a relative frequency histogram is going to be a bar graph that represents the, oh wow, okay, whoops. A bar graph that represents the relative frequency of a data set, and you had that as well. And in a little while, I'm going to give you some data, some different graphs basically, and you're going to have to tell me which it is. Is it a frequency histogram? And it's off the data that you have, off those numbers. Is it a relative frequency histogram, or that last one up there that I have just found out I've been mispronouncing for about a decade? Oh, actually, ogive is correct. Okay, I've been going agiv. Ogive, something like that. But it is actually ogive. It's actually how it is pronounced. You almost look at the G as a J almost, and it's ogive. Okay. Basically, all it is it's very similar to the frequency histogram and relative frequency histogram, but basically you just use all it is a cumulative frequency graph. All right, that's all it is. But again, it's one of those where mathematicians, let's just give it a different name so it's shorter. All right. Basically, but this one, how's it different though than the frequency and the relative frequency histograms? It's a different type of graph. Yeah, it's going to be a line graph that displays the cumulative frequency. Okay. remember, cumulative means the class you're at and all before it. You got to kind of add it up, cumulative, right? So I'm handing out now basically kind of something I came up with, well, about 45 minutes ago, to be honest. And I think I did a pretty good job with the time frame I had. And like I told you, I'm going to give you, you can keep your first set of notes out because we're going to use that data that we already kind of organized. We put it in a nice histogram, right? Or we put a nice little table there. And so now let's see, yours came out better than mine, but that's all right. So determine whether each of the following graphs is a frequency histogram, relative frequency histogram, or a cumulative frequency histogram, okay? Or an ogive. And I cut some stuff off on purpose. You notice that there's a label on the horizontal axis, but I have cut off the label on the vertical. Because if you were to be able to read that, you'd know exactly what it is right away because it kind of tells you what it is. So I've cut that off. So in other words, basically you don't see anything, you know, no label over here to tell you what it is. So base it off of your data. Well, what are these numbers? I mean, here's 12.5. Where's that number? And 24.5. Does that number show up on your little deal anywhere? And over here we've got 2, 4, 6, 8. So here's 6 for this one apparently, 10, 13. You know, where does that stuff show up? What's it being shown? So where do these numbers show up? Those are the midpoints, right? Well, where do these numbers show up? Where do those numbers show up? Aren't those the frequencies for each of those? Now 12.5 basically is the midpoint of that class, right? And so that is just the frequency, and it's a bar graph, right? So of your definitions that you just got, which one's supposed to be a bar graph that shows frequencies? A frequency histogram. I told you you can use midpoints. You can use the marks if you want, all right? So that is definitely a frequency histogram. Okay. Well, the next one's a bar graph, right? So are we guaranteed that to be a frequency histogram? Is then the question. Well, looks like these, and here's those numbers I was telling you about. Here's your class boundaries, right? That's not really overly important, but I just wanted you to know where those numbers were coming from. Okay, why it wasn't, say, 7 to 18. But how are these numbers different from those numbers? Yeah, where are those numbers? Those are the relative frequencies, right? So this is a relative frequency histogram. Relative to the entire data. It's percentage, basically. That's why they call it relative frequency to the whole data. That's why they give it that name. You notice, really, could I kind of take the one bar graph and put it, based on how they spaced everything, couldn't I kind of put them right on top of each other? And wouldn't they look the same? But that's because they spaced everything evenly. All right, you see how everything kind of got spaced fairly nicely? That's one thing you definitely have to watch out for when you graph things. You want to make sure that you keep it true to what it's supposed to say. Keep things even. Don't try and distort the data. It is unethical to do so, which of course means lots of people do it and makes a lot of money to do it. Okay, so we've got a frequency histogram and a relative frequency histogram. The key here is they were both what types of graph? Bar graph. That's what you're going to get there. And basically all you had to do was look at that axis and see what information you were getting. Over here I was getting a percentage on that relative, and on the left here I was just getting the actual frequencies, how often it happened. Yeah, kind of that's what they would put there. Relative frequency, you know, based on whatever is what they would put there. And then over here they would just say frequency. And obviously that's why I had to cut that off, because otherwise it would give you the answer right away. All right, I wanted you to look at the numbers, find out where are they coming from. Okay, so why don't you take a look at these three and see if you can give me any of them. I'll give you a second. Why don't you try and see if you can answer all of them. I'll just pause it here and see if you can do that. All right. Anybody think they know any of them? The bottom one is apparently an ogive. Do you agree? Does that show, because ogive is supposed to show what? Cumulative frequency. Is that what it shows? Yeah, because it goes up to 50 and it keeps going up. I agree with that. That's the ogive. Anybody else? I think they know one. Yeah. Very good. I doubled one up to see if you would figure that out. That is a frequency histogram. All they did, though, is they just kind of used, you know, the class boundaries. So that is a frequency histogram. Very good. Because, yeah, you look here. What are those? They're the frequencies. Okay, it's not the relative frequency. It's not the cumulative frequency. That's just what it is. So they have kind of a lot of liberty down here as to how they want to show that to you. Okay. Which leaves us with that one. Yeah, it was a trick question. It's none of them. But what does it show us? It does show us the frequencies, right? But it's not a frequency histogram based on our definition because it's not a bar graph. Okay, so this is basically what they'll call this a lot of times. It is still a frequency graph, but they'll call it a frequency polygon. Because a lot of times it will kind of end up looking some kind of like a polygon when you connect them. Okay, that's why they call it a frequency polygon. But really, isn't it showing you the exact same information that the histogram is, just a little bit different? Okay. And those of you that had calculus, these are the ones that'll scare you when we used to do the midpoint approximation, right? Well, I missed on that one, but you get the idea. Yeah. Yep. So believe it or not, there is a lot of, it does help to have a calculus background because of some of the stuff we'll be doing. You don't need it, but it does help to have one because you can see things in the data that maybe otherwise won't. So those that are in both right now, as we go along, I think things will kind of mesh together fairly well. Okay? So, did you have a question, or was it just one? So you think you got those pretty well figured out, what they would look like, the differences?